one with some probability. Most probability problems that you're going to be getting. Yeah. You can figure out with a Venn diagram. Please. Huh? Oh, Venn diagrams are not okay. Nope, logic is a huge part of math, and Venn diagrams are actually okay, cool. Then we don't need phones. Let's just go back to hitting things with rocks and eating.
I'm down with that.
That's pretty much where we're at. Okay. Except for you would only live to like your mid-30s.
So I'm fine with that. Why would you want to be old?
You would be currently middle-aged.
I'm good. You don't have to deal with kids anymore. Actually, you have to.
All right.
I'm with it.
We have a total of 437 students that get pulled for this. Some of them like hamburgers, some of them like chicken. The people in the middle there, they like chicken and hamburgers. It told me how many there are in here, 47, right? Okay. So, we need to figure out how many are over here and how many are over here, right? We're told that a total of 306 people like hamburgers, right? Well, 47 of them like both hamburgers and chicken, right? So, in order to find the people that only like hamburgers, I have to subtract 47 from 437, right? My bad, 47 from 306. Sorry about that. So some of these people that like chicken also like hamburgers, right? So in order to figure out what this is, I need to get my total people who like chicken and subtract 47. $106. All right.
What are those? Did you subtract 47 from
306?
and then you subtracted 153?
Yeah, this one's 47 from 153 to get 106.
Okay, and then 47 from
Yeah.
106.
And now it adds up, right? My total people who like hamburgers adds up to 306. My total number of people that like chicken now adds up to 153. That's what I need. Because it wants to know how many people, or what the probability is, or the proportion of people that like neither hamburgers nor chicken. So this total across here is the total number of people who like chicken, they like hamburgers, or they like chicken and hamburgers. You know what I mean? So that's going to add up to something. Right? And if I wanted to find out how many people like neither, I would take my total number of people, and I would subtract all those people that like hamburgers, or they like chicken, or they like hamburgers and chicken. Right? So that's how we'll do that. That turns out to be 25. Remember, when you're finding a probability, and you probably learned this a very long time ago, probabilities are always like your total successes over your total number of possibilities. Or you could say your number of counts over your total counts. So 25 out of 437 people, you could also write it as a proportion, like neither. So like I don't do hamburgers or chicken because I don't eat things that are alive that have faces. I'm vegetarian.
You know, they want to be mad. They have souls and they feel like even if they're dead.
I just want to be conscientious. Sorry. I can only say that because I was raised vegetarian. I didn't eat meat till I was 13.
Oh, that's so nasty.
Done? Okay. Part B of this question is weird, and I'm sorry, but if this question was on an AP statistics test, which is kind of where it belongs, you would be given formulas. You don't have these formulas that they're writing down here. The only thing that you might know, and you now know it because I'm going to tell you, is that if two events are independent, they do not have any events in common. Right? In other words, they are mutually exclusive. That might have been be a word that you've heard before too, okay? With that definition in mind, we can say that people that like hamburgers and people like chicken are not independent or mutually exclusive because there's an overlap. There are people who like both chicken and hamburgers, right? So because there's an overlap, we would say that they're not independent. So the best that we can do without formulas is cancel those two questions out. And then we got a 50-50. It turns out that events H and C are not independent because the probability of H and C does not equal the probability from H times the probability. I'm almost positive. I would want a formula for this too if I was you. Here it is. In case you were curious about the formula. There it is. And really, honestly, on the AP statistics test, you get these formulas. Unfortunately, on this particular test, they're not going to give you these formulas. So the best I can give you is to break that down, get it down to a 50-50 choice. So there are going to be questions on the part that are like that. So the best you're going to be able to do is at least increase your chances of guessing the correct answer. Okay, but it's better than not. So, okay, yeah. I'm not sure how we got way up here. Here we go. Hey, Mr. and Mrs. Ryan sell and they build nesting boxes for small birds. If they were Russian nesting boxes for small birds, they would fit inside each other. Right. Okay. So it wants me to write an equation, n of x. We want to know the amount of money they expect to receive this month. They've already sold, so it's $19.95 per box. Because it's our variable. Plus, they sold 74, right? We gotta have a variable in there. That's how many boxes. And it changes, right? Boom. That is the first answer. What's the average rate of change? Isn't it the same thing as the slope? So there it is. There's your rate of change right there. The rate of change is 19.95.
Oh, so you built this like a...
I made a linear equation.
Huh.
This is an Algebra 1 question all day. So I don't want to spend a lot of time on it. Cool. Here's an Algebra 2 question. You want to know about domain? Sort of. Should be an Algebra 1 too. Hey. Already made 74, right? So then x, and x can't be more than, if your total number of boxes made can't be more than 450, then x can't be greater than 376. It can't be exactly 376 because you're allowed to make 450 boxes, so that's why we choose D. Huh? Similar to BART? These are actual questions from the 2015 part. These are actual part questions. Not the one you're going to take, of course, because that would be cheating. But
I feel like it would be cheating. Because I would have exactly.
Yeah.
Mr. Roman, so why did we pick number B? Isn't it greater than or equal to, right? If you can't build more than 450 boxes, then...
So he's going to give you one box less. We already made 74 boxes. It's like a trick question. They want you to recognize, or they're being tricky. All right. This is our profit, right? Our profit would be the amount of money that we make minus the amount of money that they sell a box for, minus the amount of money that it costs to make a box, right? Times the amount of boxes made, right? That's going to be equal to P of X. No problem. Super easy. This is really an Algebra 1 type question. It's just I think that the wording is fairly complicated. And that's why maybe it's on this test. That's the answer. This is an S.
Oh, no, it's flat.
So this is an S. Is that better? Sort of. Okay. I don't like it when they put S's in problems because my S's don't look good. A, we just got done doing this. Awesome stuff, right? Okay. What does this series look like? Looks like 1,000 plus 1,000 times the 10%, right? And it keeps going. So what is this? This is your rate, right? So then, there you go. Oh my gosh. I'm sorry, I reverted to the next problem has 10%. I've already, sorry, I've done a lot of different, no. I want to raise, I'm sorry. The next problem that's like this, an interest problem, is going to have an interest of 10%, and I just combined these two, so there we go. Sorry about that. It says 2% greater. So R is 1.02. Sorry about that. Huh? And my eraser doesn't work, so that's great. It worked all day until I made a good mistake. No, it's. I haven't figured out what it is.
Pausing and erasing it.
Let's just do this. If we're gonna do this, we're gonna use this formula. N is equal to 30, and R is equal to 1.02. That's it. Just plug it in to your calculator. It spits out a number. That number is gonna be there.
Where was the where's it go on like that?
And there's, sorry, it's going to go up to 1,000 times 1.02 to the n minus 1, really. In that one. Too many things to finish.
Wait, this is over to
I added 1 plus 0.02. That's what this arrow means right here.
Oh, okay.
Okay. This is a great question. Which expression is equivalent to this? Hey, I see all these 2's. Do you think maybe the greatest common factor of all 3 of these is 2? Possible. I'm not going to guess at it. It is. It must be, right? So then this is going to be equal to 2 times 162 divided by 2 is 81. 144 divided by 2 is 72. And 32 divided by 2 is 16. All right. Select all that apply. Well, be careful. Don't choose this one. Please don't choose this one. Oh, it's 72x, not x squared. Yeah. Oh my gosh. Yeah, I almost picked it just now. Like, I was like, oh, look, we just did that.
Sounds like last I thought it was.
Yeah, for sure, right? Okay, so looks like we need to factor this. Hey, this looks like a perfect square trinomial. Factors like that. All right, so look, I can choose this one. Yay. Hey, but you know what? Each one of these are also perfect square trinomials. So it turns out that 9x squared minus 4 is also, it's 9x squared minus 4 now is difference of squares. So the first one was a perfect square trinomial. 9x squared minus 4 is difference of squares. That's 3x minus 2 times 3x plus 2. That's that one. This one is also 3x minus 2 times 3x plus 2. Okay, so where's my other one? Boom. F. That is a lot of factoring. I had to factor that thing 3 times.
It's what that trinomial thing.
A perfect square trinomial means that, so this is, I could rewrite this as 9x squared minus 4, the whole quantity squared, right?
Yeah.
And that's what a perfect square trinomial is. You just have to figure out, I see that this is a perfect square, and that's a perfect square, right? So it looks like I got to put a 9 here, and a 9 here to get the 81. And the way that I would get the 16 is with a 4 and a 4. And if you see that these two end numbers are squares, then the square roots are going to be the two outside numbers there.
Okay, so if the two end numbers are can be squared, then chances are one of them.
For this one, I'm going to write the formula real quick, okay? It's an interest problem. We just did these, right? You start with $500. What's our rate? 1 plus 0.1 to the t. And there's our interest formula we made. It's an exponential formula. It's an exponential equation. To answer each one of these questions, you're just going to plug this in your calculator for different values of t. Okay, so let's get out our handy-dandy calculator. In 1 year, what does that mean? That means that we're going to plug in one for our exponent. 550. Is it true? The value will increase by 50. Yeah, right? 550. How about 2 years? All we got to do is go to our calculator. And instead of 1 for our exponent, we will put 2. 605. What did it ask us? The value will be 605. Yes. Hey, what is 30% of 50? 3. It's just such a gap. Sorry, 30% of 500, I meant to say, first of all. Yeah, so then 500 will be 150, right? So we need to see, hey, did it increase by 150 in 3 years? Let's go to our handy-dandy calculator. And put 3 in. No. It did not. Right? It went up by 165.5. So this one's out. The rate of change of the value will decrease over time. Is the change ever going to decrease? Is the value ever going to decrease? No, it's not. All right. A linear model provides the best fit for the estimated values. Is that a linear model? No, it's exponential. Boom, we have our 2 answers. Excellent. The appraisers, I need this formula stuff. Hey, we've already answered this question too. Right? It is going to be C. Right? We made the formula already. Right. Which, this problem sucks because if you didn't use the right formula, I mean, I guess you could figure it out without using a formula, the first question. But if you get the formula, the question's easy. And then if you get this wrong, you might go back and go and change your answer to the previous one. It's nice to have double jeopardy a little bit. Right? Yes.
Do you find it by doing it with all of those formulas?
What do you mean?
Like go to part B and then use one of those formulas to find the answer and just go through them all.
Yeah, but you don't know if it's the right answer yet. No, I wouldn't do that. That would be. It's an interest problem. You guys should have that down. They're not that bad. We spent a little bit of time on it. Okay. This wants to know for 5. So the problem is if you got this one wrong, then C is going to be wrong. Because in order to get C, you've got to plug in 5 here. So you get 805.255. That's what's going to go in here. Anyway, sorry.
Well, all these problems just insert stuff in like formula.
Yeah, that's it. That's all I've had to do. For part D, it gets a little more complicated. We want a rate of change. Remember, our rate of change formula is f of b minus f of a over b minus a, right? It's our change in y over our change in x. So in other words, what we want is over the first 5-year period. So we're going to go x equals 5 minus x equals 0 in our formula that we have, right? And then f of 5, which turns out we have here already, right? Or when t equals 5, sorry. T equals 5. Not when x equals 5. That's 805.255 minus, when you plug 0 in for t, you get 500, right? This is going to give you your average rate of change. That gives us 61.051. So that is how you find your average rate of change. Yes. This is really easy. We're not going to do this one. We don't have time. This is a super calculatory question, right? You can get this done with your calculator. You really need your calculator for this. So I'm going to show you the solution because I got calculator pictures and all kinds of stuff for this one. So first of all, for A, how many hours after the ticket window opened did the number of people in line reach a minimum before increasing? What's the answer? 3. It's that point at 3. Okay. So we've got a graph, and then they model it with something, and they model it with this polynomial, right? This polynomial is nasty. I want to put that in my calculator right away and graph it, okay? So I'm going to graph that in my calculator immediately. And it wants to know how many hours after the ticket window opened did the number of people in line reach a minimum before decreasing. So we're going to go to our handy-dandy calculators. We're going to graph that. And then remember I showed you how to use that minimum function on your graph? I will show you again. And again, this is all in the solution guide. Yeah. All right. So part A. We're going to use the min function on our calculator to find the value 0.3. Where is that minimum? if you have a graph, you are going to go to your calculator. So if you're on the graph, I don't know what we have graph. This one's not going to have a minimum, darn it. But you hit second calc, and you choose minimum. Remember that? And it asks you between where and where. And you look for where the graph drops, right? So in this case, I would put between here and here. And that gives me a minimum value of approximately 3.
Yeah.
All right, we use the minimum function for the next one. So we looked at our graph for part C. Let's look at part C. Part C says at 11 a.m. approximately what was the difference between the number of people in line as recorded from the graph and the people in line as predicted. So at 11 a.m., where's 11 a.m. over here? 11 a.m. If we start at 9, this is 10, 11. So it says 2, right? What's the difference between, so now we're looking at what x equals 2 is on our graph. So in order to find that on your graph, you can go to your graph and hit trace, and then just hit the number 2. Enter, and it will spit out maximum of 6. I'm sorry, what does it say? It spits out, I apologize, I was looking at part D. Going ahead. What is it? If you hit trace to enter, does it spit out 22.8? 22.88? So you can find it doing that with your graph, or you can just plug it into the function. And then you're going to find the difference. You're going to subtract, right, at 2, at x equals 2, darn it, your number of people is 20, right? So you go 20 minus whatever you got from your calculator. And you can do the same thing for part D. Why are you? So based on the model, f of t for what values is of t is the number of people in the line predicted to be increasing?
Really?
We can look at our graph again. Not that. So it is only increasing from 3 to 6. Remember, because we have a minimum at 3, and then we can calculate a maximum at 6 using the same function. And we know that the only place where it's increasing is between the minimum and the maximum. Okay, I really need to find a normal distribution problem for you guys. We're going to skip to 27 because this is a normal distribution. So remember, at the end of first semester, we did these things. Okay. In order to answer this question, we are actually going to go to our calculator. We're going to hit normal. CDF. Actually, I'm going to go ahead and get the solution. This is the important part. The normal CDF. Remember, you have your lower bound, your upper bound, and then you have your mean and your standard deviation. Okay? You just have to put that in your calculator. It spits out the correct answer. Huh? It is. Lower, upper, mean, standard deviation. My life is a meme.
We have 1 minute for class.
Alright guys, the rest of these will be on the next video. If you want to check it, it'll be up after 7th period.